Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called number of subarrays with bounded maximum. So in this problem we have been given one array of positive integers and two positive integers left and right, where left is less than equals right? What we need to do, we need to count all the contiguous non-empty subarray such that the value of the maximum array element in that subarray is at least left and at most right. What does that mean? That means is if we are getting any subarray, we need to check the maximum array element in that subarray that we are finding that should be in the range of left and right. All right, the constants are these two constants, that left and right, and nums will be nums I will be in this range 0 to 10 to the power 9, and the length maximum will be 1 to 50,000. All right, let's quickly jump to the whiteboard just to see this problem, what this problem is saying us to do. So basically it's 2143 here, right? So one subarray is 2, that is in the range of 2 and 3. One subarray is 2 comma 1 because 2 is still meeting this criteria, that is still in the range 2 and 3. However, 1 is not meeting this criteria, but we are fine, right? Because 2 is still maximum, should meet this criteria. If I say 1 comma 4, is it the valid subarray 1 comma 4? No, because the maximum is 4 here, and 4 is out of range of 4. Out of range of left and right, so 4 is greater than 3, so of course it is not meeting the criteria. So that's why 1 comma 4 is not our subarray. All right. So and can 1 also be subarray? No, because 1 is also less than left, because remember the condition has been given in the problem itself, that subarray such that the value of the maximum array element in that subarray is at least left and at most right? So at least we should find one, at least one element in the subarray that is in this range, right? So 2 is fine, 2 comma 1 is fine because 2 is also in the range, 1 is not in the range, but still it is also not crossing, at least we are having another corresponding pair, that is 2, that is still in the range, right? So 1 is not fulfilling the criteria, but it's fine. 2 is having, and 2 is the greatest element in this subarray, right? So 2 comma 1, 2 is the greatest element, that's what it's saying, the maximum element, and we need to check the maximum array element that is in the range. So in this case 2 is the maximum element in this subarray 2 comma 1, and 2 is in the range. All right, 3 similarly is valid subarray because 3 is also in the range, 2 and 3 inclusive. So we need to check like greater than equals to 2, less than equals to 3, so it should be inclusive 2 and 3 when we are saying within the range inclusively. All right, so that's how the output would be 3 here, right? So we need to return 3. Now I hope the problem is clear now. Now let's move to the solution part, how we are going to solve this problem. So basically we need to count the number of subarrays here, right? What does that mean? We have been given the condition, so we can use the condition, right? We can just use the condition, we can just find, we can just iterate this array. First of all, we can just find, if we find any element that is in the given range left and right? So if there is any element that we find in the range, then we can just go ahead and calculate the size till that item. How we can calculate the size of till that item? We can have two pointers approach here. The advantage of two pointer approach would be here, that let's say I am having one pointer that is I, and that is, let's say, running pointer, right? So this is the running pointer, and I am also having another pointer that's called J, right? That is not the running pointer, but basically I can calculate the size with the help of I minus J, right? So let's see here, okay? And this is second pointer. This is just an idea, that's how we can solve this problem. So let's say I'm at the index 0, and then I find this 2 that is in the range, and then I can say 0 minus 0 because I will be 0, J will be 0, and then the result will be 0. So of course it is not 0, we are having one element here. So in that case what we can do, we can just say I minus J plus 1, because this is index is 0 based, but we need to count the element. So basically we need to add 1 so that we can count on top of the index, because we are counting not the index based, right? We are actually counting the numbers. So when we are counting, we need to add plus 1 so that we can just we can just get rid of this index kind of thing, right? Because index starts with the 0 and we need to actual count, so we need to add +1 basically. So basically our formula comes something like this. Our formula will be like something I minus j plus 1, right? That will be the count. Similarly, we will be checking for 1. Okay, so if we will check the condition, okay, if 1 is in the range, no, it is not in the range, but still we need to consider this number as well, right? That is 1. How we will consider this number? In order to consider this number, we will be checking, okay, 1 is there, right? And 1 we find, but whatever the previous count it is there. So previous count we calculated it as 1, and then we will be accumulating this count whenever we will encounter this scenario. So the actual count will be 2. Okay, so this is the second option. So let's note down here as well, so that we don't get a track. So first condition would be basically it should be within range, right? Second condition is there, basically it is not within the range, right? Not within range, but but basically it is less than left. Why we are checking less than left? Because remember, we have been given the condition where as per that condition, it's the maximum element should be in the range, right? So that's why we are checking that, okay, the next element should be less than the left, right? Because it cannot cross the given range, right? So maximum element we already checked, considering that it should be less than the left, then we will only that in that case only it will be eligible to get the count, right? Otherwise it will not be eligible. Similarly, we have seen like, okay, is 4 1 comma 4 is the valid subarray? No, it is not, because 4 is crossing the range. It should be in the range of 2 and 3. All right, so that's why the second condition would be it should be less than left. All right, the third condition is there will be it is out of range, right? So out of range means this condition like 4. In that case, just go ahead and reset our variables, right? So let's do this. Let's create a skeleton at least, and then we can just go ahead and see what we are going to do. So as I mentioned, we can take the 2 pointers. So let's say I'm having another pointer, that is j, right? And we are having one running pointer, right? That is, let's say, nums length I plus plus. Now let's go ahead and mention all these three conditions that we have discussed so far. So within the range, how we will be checking? We will be checking, okay, if nums I, if it is greater than equal to left, right, and this nums I is less than equal to right. So this is our first condition. All right, now what is the second condition? Second condition we have discussed so far, that that is not within the range but less than left, right? So second condition, if it is less than left, right? So let's say nums I, if it is less than left. And because this is because of this condition that we have been given, that okay, we need to find non-empty contiguous subarrays such that the value of the maximum array element in that subarray is at least left and at most right, right? So it cannot cross the right side, but we say at least left. At least left means it should be at least left. So we find this scenario, right, 2 comma 1. So 2 is already there. We find one element that is in the range, but let's say next element is less than left, right? We need to consider that scenario as well. So we need to count 1 as well here. So that's why we are taking less than left, but we cannot go greater than right, because we cannot have those scenario because of this condition. So we need to understand this condition properly, that this is the, we are checking the value of the maximum array element, right? Else is it is out of range, right? In that case, basically it is out of range. So these three conditions, if we are clear, then we are done with this problem. That's it. Now let's have let's say result. This is our result, and how we are calculating the result here. So let's say as I mentioned, I minus j plus 1. So this will be our result. And now basically how so basically in this case, where the corresponding array element is less than left, in this case what we are going to do, in that case what we will be doing, so result, we will be keep accumulating all these sizes. And here in this case, let's go to whiteboard again here. So let's say we are coming to 1, right? And 1, how we will be calculating the size? We will be checking like how many elements we encountered before 1. So we encountered only one element. So in that case, what we will be doing, we will be adding that counter. So let's say we take another count variable here, so that we can achieve our goal. and that count variable, let's say that would be I minus j plus 1, I minus j plus 1. And then similarly what we will do is result plus equals to count. Why we are doing that? So the reason we are doing that, so that we can have this counter will be always will be giving us whatever the value we have encountered so far, right? And then we are not accumulating this, right? We are just simply doing okay I minus j plus 1, so it will be just giving that range. And then once we encounter this scenario that is less than left basically, then we are accumulating this count, right? And we are accumulating this count as well if it is within the range. So this is the crucial point that we have to understand. Third point is, if it is out of range, then we don't need to do anything. We will just reset our j pointer, right? Because let's say we encounter to this situation whether it's 4, then in that case what we will do, we need to reset our j, we need to increment our j to I plus 1. So let's say I is here at 4, and then our if I is there, right? If I is there at 4, then j also we want to move further to the index 3, because I will also move to the index 3, right? So we want to move forward our j pointer as well to have the correct calculation in the next iteration. So that's why we will be doing j I equal to j plus 1, and then count will also be, we will be resetting to 0, because now this will be the fresh counting, right? We accumulated all the result basically till this situation, but for the next iteration onwards we want to have the new count. That's why we are resetting the count itself. So if this is clear, then this is done, right? So there is nothing else we can do. So this is the thing here. Takeaways or the quick summary of this problem is basically we need to pay the attention of this condition that we have been given, that the maximum array element in that subarray is at least left and at most right, right? So this is the crucial point. Once we understand this condition, then we can pay the attention of this detail, and then we can come up with these three conditions. First condition is within the range, we can find within the range. Second condition is like this scenario 2 comma 1, right, where it 1 is not in the range but it is still less than left, right? So that will be our else if condition. Third else condition will be like it is total out of range. So that is the time that we have to reset our counters. We have to reset our counter, and we need to move our second pointer to the next index. So j equals to I plus 1. So that's, if these three conditions are clear, then this problem is pretty straightforward, and that's what exactly we are doing. Another tiny point that we need to take care, that result we are accumulating every time. And then once we encounter this scenario, a second else if condition at the line number 15, then in that case we are just doing plus equals to count. Why we are doing that? Because once we encountered 1, we need to make sure that okay, how many numbers, or what is the count till this time, right? So that's why we are just getting that, reusing that count, and then we are accumulating basically to the result itself, just to make sure that we already seen this valid range that is in the count, and then we are accumulating this into the result. So that's why we are doing this thing. And third is definitely we are just moving to the second pointer and we are resetting the counter. So hope this makes sense. If we quickly check the time complexity and space complexity, time complexity is linear, and space complexity we are not taking any space, so it will be order of 1. Let's check for the syntactical error if there is any. If there is not any, then let's go ahead and submit, and let's see if it is working or not. So looks like this is working fine. So hope this makes sense. Thanks a lot. Have a good one. Bye.